All right, this is the answer key for the Wednesday night's homework, Chapter 16 homework, Part 2. And so I'm just going to leave these up here. This is the discrete and the continuous answers. Remember that the discrete are distinct, countable amounts. The continuous would be infinitely small measurements that you could be making. So too many to count, too many possibilities. All right, so those are the answers for the section 1 through 8. Now, this problem here, starting with number 9, this is again just seeing if you could do this formula right here. Okay. Oh, do you know, I think that I forgot to tell you, I may have forgotten to tell you to not include this 0.1 right here. So that's going to throw up your answers on B and D. The reason that that was a mistake is because if you have this 0.1 probability in there, you have probability greater than 1. So I had intended on telling you to take that off. All right, so there are your answers for your parts A, B, C, and D. All right, next. Okay, this one was kind of strange. So this is what the intent of creating this probability model was. For holiday 1, you were going to be picking 50 candies, of which you expected 50% to be red. And 2, you were going to get 60 candies, 30% of those would be red. Holiday 3, you would get 70 candies, and you would expect 20% of those to be red. So in total, you would expect from all of those holidays to come out with 57 red candies. All right, now with 11, what happens is you have a dice game, and you get $5 for rolling a 3 or a 5. Apparently, in the instructions, there was no cost to play the game. So you got $5, and on 2 out of 6 ways you can have that, so that probability is a third. Or you lose $2 if you get something else. Okay? So, and that would be you lose $2 2/3 of the time. So you would do that expected value, and that expected value is 1/3. So overall, in the long run, on average, you would be making a third of $1, so I guess 33 cents on average each game you play. So hey, you should do that. You should play, because overall you're going to be winning. The standard deviation for this is $2.28. And what would you expect to profit for 30 turns? So if this is how much you were making on average per turn, and you have 30 turns, then after 30 turns you would expect to have about $10. Now, this is an extension question. So here, I tell you what the standard deviation for 30 turns is. I had to tell you that because that's actually something another day we're going to learn, is how to do that for the multiple events. But I want you to draw this normal model. And this is with the profit at 10. And the question is, when will you make at least $15? That's 15 or greater. So you had to draw the line here where $15 is, and you want to make that much or more. So I found a z-score. It is just 0.2767 standard deviations above the mean. When you norm CDF that, you have 0.391. So there's about a 39% chance that you could earn $15 or more on 30 turns, you know, on average. All right, goal 4, this is the adding and subtracting thing. So we are going to be turning the amount of cars that you sell. See, this is the transformation. Cars you sell into your salary or your commission. So your expected total pay would be, in this case, affected by both, the 300 plus the 250 per car sold. So that's 300 plus 250 times 3.1. So on average, you would be making $1,075 a week with this standard deviation of 275, because the standard deviation is only affected by 250, the multiplying factor. And part C is an extension. So this salesperson wants to know the probability that she would average 1570 in a week. So here we draw the normal curve with the average at 1075, and we want to see where is this mark that 1570 is, and I want to make that much or more. So I find the z-score for 1570 minus the mean over the standard deviation. That's 1.8 standard deviations up. When I find that area, it's 0.0359. So there is about a 36% chance that the salesperson will average 1,570 a week or more. All right, so goal number 5, when we are combining more than one variable. In this case, we have 2 different intersections, and they have a different amount of cars that are turning left at these intersections. So we first want to know the combined total, so the means just add, and that is combined total of 42 cars on average at those 2 intersections. The standard deviation goes through the Pythagorean theorem of statistics, and so that's about 8.06 cars. Okay, that's the variation that you would expect above and below the 42. All right, and then part C is the one that is the extension problem, where we get this into the normal model. And the city council is hoping that the growth is not too fast. So what they want to know, what's the probability that this combined total is going to be 30 cars or less? So you have to find the location of this 30 cars in relationship to the mean. So the z-score is 30 minus 42 over the standard deviation. That's just 1.5 standard deviations, 1.49 standard deviations below. So that's not too bad, but we do see that that still is just leaving the council with a 6.8% chance that the information or the particular data they collect is going to show 30 cars or less on average combined between those 2 in the intersection. Notice that this down here is saying combined number of cars turning left at the intersection, and so then of course this is the average combined that you're coming out with. All right, and number 14, this is the viscosity of the liquid and the amount of time it's taking. So we have liquid Q and liquid W. Liquid Q is faster because it's taking less seconds than liquid W. Now notice, when I want to find this difference, you need to notate the order that you are subtracting. That's very important. So I did the order of the W liquid minus the Q liquid. And so that was 4 seconds. It was a positive value of 4 seconds. And so then my standard deviation, of course, goes through the standard deviation of statistics, still adds right here. So that standard deviation is this 3.61, and again, these are seconds. All right, so here is the extension problem, the one that gets this going into the normal curve. So here we go. We are wanting to find the probability that Q might take longer than W. In order for Q to take longer than W, well, first of all, if W and Q are equal, then W minus Q is 0. So right here they are equal. So let's think. On this section, W minus Q is positive, so W is larger. Over here on the right of the 0, W is larger. All right, but we are wondering where Q is a larger number. That would be over on this side. Over here, Q is a larger number because when you subtract, Q is a bigger number, and so, because it's larger, So you're getting a negative value there. So I first find where this line that they are equal is located, and that's the z-score, where the difference is 0, minus 4 over minus the mean over the standard deviation. That is 1.11 standard deviations down. So when I norm CDF from negative infinity up to that, I get 0.133. So there is about a 13.3% chance that Q oil is slower than W oil. Of course, that means took longer or more seconds. Okay, longer time. All right. I'm going to let you think about that for a second. And I think that's all of them. All right, so I'll leave that there for you to look at if you need to, but it's really important that you get this idea and understand what's happening on the left and the right side of the equal mark. The left and the right side of the equal mark. And so that is the answer key to Chapter 16, Part 2.